Hi, my name is Jin Yoon, and I'm a master's student in Stein Monogastric Nutrition Laboratory. Today, I'll be discussing about one of my thesis researches, which is entitled Energy Concentration and Amino Acid Digestibility of High Protein, Low Oligosaccharide, and Conventional Full-Fat Soybeans Fed to Growing Pigs. This is the outline of the presentation. First, I will have an introduction. Then I'll show you the nutrient composition of soybean products used, then data from energy concentration and amino acid digestibility experiments. I will end this presentation with the overall conclusions and take-home message. Soybean meal is the most commonly used protein source in swine diet. However, soybeans contain oligosaccharides, which can decrease digestibility of energy, reduce growth rate, and affect fecal consistency in weanling pigs. Conventional soybeans contain 4 to 6% of oligosaccharides, which are mainly stachyose and raffinose. Soybean industry has been able to produce new varieties of soybeans through genetic selection, which contain less than 0.5% of oligosaccharides to reduce the adverse effect of oligosaccharides when fed to pigs. Through genetic selection, soybean industry has been able to produce high-protein soybeans as well. Studies have shown that high-protein full-fat soybean has greater digestible crude protein and amino acid concentrations than conventional full-fat soybeans. However, this was only due to greater total concentration of amino acids and crude protein because digestibility values did not differ between high-protein and conventional full-fat soybeans. Soybeans are most commonly used in soybean meal form in swine diet. Conventional soybean meal is produced by hexane extraction, so it contains less than 2% of fat. However, studies have shown that added oil can increase digestibility of amino acids by slowing gastric emptying, reducing passage rate of ingested feed, therefore lengthening the time for amino acids to be absorbed in the intestines. Therefore, we use these 3 ingredients in our experiments: conventional full-fat soybeans, high-protein full-fat soybeans, and low oligosaccharide full-fat soybeans. These are the nutrient composition of full-fat soybean products used in the experiments. The conventional full-fat soybean had dry matter of 95.97%, high protein with 96.99%, low oligosaccharide with 94.75%. Gross energy was 5,536 in conventional full-fat soybeans, 5,485 in high-protein full-fat soybeans, and 5,428 kilocalories per kilogram in low oligosaccharide full-fat soybeans. Ether extract was 24% in conventional full-fat soybeans, 20.5% in high-protein full-fat soybeans, and 21.14% in low oligosaccharide full-fat soybeans. Now you're looking at sucrose and oligosaccharide concentrations in full-fat soybeans used. As you can see, low oligosaccharide full-fat soybeans had very low concentrations of oligosaccharides, raffinose at 0.06% and stachyose at 0.46%. However, sucrose concentration increased to 7.96% compared with 5.63% in conventional. If you take a look at high-protein full-fat soybeans, raffinose and stachyose concentration is comparable to that of conventional full-fat soybeans. However, sucrose concentration was a bit lower than in conventional full-fat soybeans. Here are the crude protein and some amino acid concentrations in the full-fat soybean products used. As you can see, high-protein full-fat soybeans had greater crude protein and amino acid concentrations than conventional full-fat soybeans. When you look at low oligosaccharide full-fat soybeans, crude protein and amino acid concentrations were in between that of high-protein and conventional full-fat soybeans. Now I will move on to an energy concentration experiment. The objective of this experiment was to determine the concentration of digestible and metabolizable energy in conventional full-fat soybeans, high-protein full-fat soybeans, and low oligosaccharide full-fat soybeans. We used 24 growing barrows with initial body weight of 28.3 kilograms. They were placed in metabolism cages. They had 5 days of adaptation, 5 days of collection period, using marker-to-marker approach. The pigs were allotted into a randomized complete block design with 4 diets and 6 replications per diet. We have 4 dietary treatments. Diet 1 was corn-based basal diet. Diet 2 contained corn and conventional full-fat soybeans. Diet 3 contained corn and high-protein full-fat soybeans. Diet 4 contained corn and low oligosaccharide full-fat soybeans. We used corn-based basal diet to calculate DE and ME in ingredients by difference procedure. For statistical analysis, we used proc-mix procedure in ASAS with diet as fixed effect and pig as random effect. However, pig did not have significance, so it was removed from the final model. We used LS means procedure to calculate mean values, and we also used p-diff option with alpha level of 0.05 to see if there were significant difference among the treatment means. This slide shows the DE in ingredients in kilocalorie per kilogram in dry matter basis. First, I will set up the chart. In horizontal axis, we have the test ingredients: corn, conventional full-fat soybeans, high-protein full-fat soybeans, and low oligosaccharide full-fat soybeans. In the vertical axis, we have DE in kilocalorie per kilogram dry matter basis. The next slide follows the same structure. Conventional, high-protein, and low oligosaccharide full-fat soybeans had greater DE than corn. However, among the full-fat soybeans, DE did not differ statistically. This slide shows the ME in ingredients in kilocalorie per kilogram in dry matter basis. High-protein and low oligosaccharide full-fat soybeans had greater ME than corn. However, among the full-fat soybeans, ME did not statistically differ. Now I will move on to amino acid digestibility experiment. The objective of this experiment was to determine the digestibility of amino acids in conventional full-fat soybeans, high-protein full-fat soybeans, and low oligosaccharide full-fat soybeans. We used 8 growing barrows with initial body weight of 20.6 kilograms. They were equipped with a T cannula in the distal ileum. The experimental period lasted 7 days, with 5 days of adaptation and 2 days of collection. The pigs were allotted into a replicative 4x4 Latin square. We have 4 dietary treatments. Diet 1 contained conventional full-fat soybeans. Diet 2 contained high-protein full-fat soybeans. Diet 3 contained low oligosaccharide full-fat soybeans. And Diet 4 was a nitrogen-free diet. Full-fat soybean products were the sole source of crude protein and amino acids in the experimental diets, and we used nitrogen-free diet to measure the basal endogenous losses of amino acids to calculate the standardized ileal digestibility of amino acids and the test ingredients. For statistical analysis, we used proc-mix procedure in SAS, LS means, p-diff with alpha level of 0.05 as explained for experiment 1. This slide shows the standardized ileal digestibility of lysine in percentage. First, I will set up the chart. In red, we have conventional full-fat soybeans. In yellow, we have high-protein full-fat soybeans. In green, low oligosaccharide full-fat soybeans. In vertical axes, we have digestibility values in percentage. And next couple slides will follow the same scheme. Conventional full-fat soybeans had greater lysine digestibility than high-protein full-fat soybeans. However, low oligosaccharide full-fat soybeans did not differ in lysine digestibility with either conventional full-fat soybeans or high-protein full-fat soybeans. This slide shows the methionine digestibility. Methionine digestibility did not differ statistically among the full-fat soybeans. Now we're looking at standardized allele digestibility of threonine. Conventional full-fat soybeans and low oligosaccharide full-fat soybeans had greater threonine digestibility than high-protein full-fat soybeans. However, between conventional and low oligosaccharide full-fat soybeans, we did not see a statistical difference in threonine digestibility. Now we're looking at tryptophan digestibility. Tryptophan digestibility did not differ among the full-fat soybean products. We calculated digestible amino acid concentrations in grams per kilogram dry matter basis by multiplying digestibility coefficients with ingredient amino acid concentrations. If you take a look at lysine and threonine, the digestible amino acid concentrations did not differ amongst the full-fat soybeans. However, if you take a look at methionine, low oligosaccharide full-fat soybeans had greater digestible methionine concentrations than conventional full-fat soybeans. High-protein full-fat soybeans did not differ in digestible methionine concentrations with either conventional full-fat soybeans or low oligosaccharide full-fat soybeans. If you take a look at tryptophan, high-protein and low oligosaccharide full-fat soybeans had greater digestible tryptophan concentrations than conventional full-fat soybeans. However, between high-protein and low oligosaccharide full-fat soybeans, we did not see statistical difference in digestible tryptophan concentrations. So for overall conclusions, in terms of DE and ME, conventional, high-protein, and low oligosaccharide full-fat soybeans were not different. This was because the reduction in fat was offset by the increase in sucrose and crude protein in high-protein and low oligosaccharide full-fat soybeans. In terms of amino acids, conventional full-fat soybeans had greater digestibility values than high-protein full-fat soybeans for most amino acids. Except for tryptophan, high-protein full-fat soybeans did not have greater digestible amino acid concentrations than conventional full-fat soybeans, which indicates the increase in crude protein and amino acids did not help. We also observed differences in high-protein varieties of full-fat soybeans. A high-protein full-fat soybean variety used in Cervantes, Palm, and Stein did not differ in digestibility values with conventional full-fat soybeans. We also observed that low oligosaccharide full-fat soybeans had greater concentrations of digestible methionine and tryptophan due to the greater concentration of amino acids in the ingredient. For take-home message, it seems to be more advantageous to feed low oligosaccharide full-fat soybeans than conventional full-fat soybeans because they have greater digestible amino acid concentrations for some amino acids, and we did not observe difference in DE and ME between low oligosaccharide and conventional full-fat soybeans. With low oligosaccharide concentrations in the low oligosaccharide full-fat soybeans, we can also expect less adverse effects due to oligosaccharides in weanling pigs. I would like to thank you for your attention. For more information on these and other ingredients in swine diets, you can visit our website at nutrition.ansi.illinois.edu.